lesson 14, I disagree with the writers, publishers of Saxon. They have the attitude that, well, they are correct. Right triangle trig and polar coordinates are related. But where I disagree is they think that you remember it well enough from last year to review all of that in one lesson. And I know I kind of had to spend a little bit more time reviewing, especially when it comes to polar coordinates. So I think we need 2 days to go through that. So I have split lesson 14 into 2 days. Today we're just doing right triangle trig. Tomorrow we'll do polar coordinates. Today I will give you a right triangle trig worksheet. Yes, it has some challenging problems on the back. I want you to try. And then tomorrow we'll have the regular problems set out of the book. So that's what my A means there. So beginning with a little bit of vocabulary for right triangle trig problems. Angles of elevation and depression. The whole trick to that, the one important thing, they must have one horizontal side. So here is a horizontal side. If I am looking up to something else, then it is an angle of elevation. If I have my one horizontal side, and from there I look down, then it is an angle of depression. The mistake students make all of the time is I've got a building here or something, and somebody's at the bottom of it, and they look up, so somebody tries to say that this angle right there that I just labeled with a theta, the Greek letter, that is nothing. That helps us. The only one that helps is the one that has a horizontal side. So anytime you have these problems, make sure you check before you do anything else. Is there a horizontal line in my angle? If not, you have the wrong angle, which means you're blowing the whole problem and not getting it right. In addition on that, they will talk about slant range, and that just means the slanted line, the hypotenuse. So for an angle of depression, it's that line of sight that's tilted down, it's the slanted one. Up here, that line of sight is also the slant range. And then the next thing that we need to review will be those trig ratios just in a right triangle. So we're going to write those on our formula list, so be sure those are out ready to go. And who remembers the little memory thing, the acronym with some funny sounding syllables that helps us keep straight which trig ratio is which? It is indeed Sohcahtoa. I have no idea how you memorize these in German, but we remember Sohcahtoa just to help us keep straight which one is which. We're talking about the 3 basic trig ratios, sine, cosine, and tangent, which are abbreviated with the first 3 letters. But it is not ever sin or cos. It is always pronounced sine and cosine, even when we just have the 3 letters in there. So the syllables of Sohcahtoa each start with a different letter. So the syllable that starts with S, helps us remember sine, is the opposite over the hypotenuse. And I will draw a right triangle and do all of this with letters in a moment. The syllable that starts with a C, the next 2 letters A and H, tell us that cosine is the adjacent over the hypotenuse. The syllable that starts with a T then has an O and an A, and that helps us remember that tangent is opposite over adjacent. Sohcahtoa only works in a right triangle. If we don't have a right triangle, there are other methods which we will review and learn, depending on the ones we've seen before and the ones that are new this year, that help us when it's not in a right triangle. But Sohcahtoa is only in a right triangle. This opposite over adjacent stuff is only a right triangle. So here's my right triangle. I must know that it's a right triangle. And I'm going to label my sides. I'm going to let this be C, since it's the hypotenuse. And just so I can be consistent here, let me do it the same way I did before. The legs are A and B. It doesn't really matter which is which. And then I am going to give my angles names. For right now, I'm going to let this angle right here be X. So then I can write down the sine of X is one letter over another, the cosine of X is one letter over another, and the tangent of X is one letter over another. So for sine, I know SO, S-O-H, sine is opposite over hypotenuse, so I find the X, the opposite side is A, the hypotenuse is C, so my sine is A over C. What about cosine? Jack, cosine. I find my X and what letter over what letter for cosine? So in my picture, what letter's adjacent and what letter's hypotenuse? So it's going to be B over C. And tangent, Paul?
It's going to be A over B.
Because opposite is A, adjacent is B, and tangent is opposite over adjacent. What if I then label my other angle as Y? And let's do the cosine of Y. Cos, C-A-H. It is A over C. Oh, notice that's the same as what I had. The sine of one angle was the cosine of the other angle. And we'll focus on that a little bit farther down the road out of our course this year. Now let's do the sine of Y. So sine is opposite over hypotenuse. Cain, what letters do I get for sine of Y? Opposite from Y is B, so B over C, and that's the same thing that I had for the cosine of the first angle. And now it's the sine of the second angle. And finally, tangent of Y. Ryan?
B over A.
It's going to be B over A. It's going to be, so the tangent of one is the reciprocal of the tangent of the other, because we've switched what is opposite and what is adjacent. So let's review a little bit now of how we find these, what we do with our calculators, what work we show. So for this one, I need to find X, Y, and A. So I start off, I know one angle, I know I have a right triangle, so yes, I can use Sohcahtoa, and I know the 7, which is the hypotenuse. So for 35 degrees, I just said 7 is the hypotenuse. For 35 degrees, X is what? It is the opposite. So which ratio uses opposite and hypotenuse, everybody? Sine. So we write down the sine of 35 is opposite over hypotenuse. You need to write down one more step because you don't enter it like that on your calculator, and you always have to write down exactly what you type in the calculator. Multiply both sides by 7. Type 7 sine 35 in on your calculators, and raise your hand when you have that. Olivia, what do you have?
I have 4.015.
Anybody else? 4.015. Thumbs up if you have that. Thumbs down. Something else? Looks good. So X is 4.015. Okay, now let's find Y. And there's more than one way that I could find y, but it is always best to use things the book has given. What if I made a mistake on x? Then I'm guaranteed to also get y wrong if I use x to find y. So for y, let's still use the 35 and the 7. 7 is still the hypotenuse, but y is what? It's the adjacent side, and which trig ratio uses adjacent and hypotenuse? Cosine, so we're going to do the same thing. We're going to write down that the cosine of 35 is the adjacent over the hypotenuse. Multiply both sides by 7. Type that in your calculator and raise your hand when you have that. Calculators must be getting warmed up. Seeing hands up a little faster. Amy? 5.734. 5.734. Thumbs up, thumbs down. Looks good there. Okay, now how am I going to get big A? So for big A, we're just going to use triangle sum. And so we can say that it is 180 minus the 35 and the 90. And what do we get? Everybody shout that one out. We get 55 degrees. Now let me show you another trick that I would do. If it is a right triangle, if you know you've got 90 degrees, what do the other two angles have to add up to? 90. Still triangle sum, but instead of writing all of that, I would just say A is 90 minus 35 and get the 55 that way. Say, but that's only if it's a right triangle. If you already know you've got the 90 degrees. Okay, another example here. This one's a little bit different because I don't know either of those acute angles. So, anybody have an idea of what am I going to do? Ellen?
You're going to do B, you're going to do tangent of the C, you're going to do tangent.
Okay, so I can write down tangent of B is opposite over adjacent, 12 over 5. Who remembers how we entered that on the calculator? Because that one's a little bit weird.
I don't remember but isn't it W's inverse?
And I love that you're remembering the correct name on it. It's not tangent to the minus 1, even though it looks like that. It is inverse tangent. And technically what we're doing is we are taking the inverse tangent of this side, so those cancel out and we just have B, and you're taking the inverse tangent of this side. I never write it on both sides like that. I just say tan B is 12 over 5. That means the inverse tangent of 12 over 5 is B. The angle whose tangent is. That's what inverse means. To get there on your calculator, you push your trig button, and maybe you remember that you need to, when using the touch screen, get it on the arrow first, and then it's the things in the bottom row. So you want that inverse tangent, and when it's selected, you hit enter, and then you just put the 12 divided by 5 inside of there, and we have the 67.38, and we keep the 0, rounding to 3 places. So that means our B is 67.380. Okay, C, what are we going to do there? No. Okay, we could do triangle sum, but if I got this wrong, then I'm guaranteed to have C wrong. So best way would be to say that the tangent of C is opposite over adjacent. Punch in the inverse tangent of 5 over 12. And what does that give?
22.620.
And since, well, this one had degree signs on there, so I didn't really need them, but pay attention to if you need to label the degrees on these as you're doing. Quick check, do those look like they add up to 90? So we think we're on the right track. What about Z? How am I going to get Z? Yep. Or you could say it is a triple, and you could just write down what your answer is and be done with that for Z. If you don't remember 5 12 something is a triple, then you're going to do 5 squared plus 12 squared is Z squared, so 25 and 144, so 169 is Z squared. And what's the square root of 169, everybody? So you could have just said Z is 13 because it's a triple, or you go through and use Pythagorean theorem.
It's just that.
It means values that we've memorized work for a right triangle. The most basic one we know is 3, 4, 5 makes a right triangle. And there's some that we just have seen so much that we've memorized them. And if they're those that we know all the time, they're integers, we don't have to do Pythagorean theorem to get it. We can save time and say, oh, that's one we've memorized, and write it down, but if we don't remember it, then we do the work. So, a little bit of review. If you have a right triangle problem, what tricks are now in your toolbox to solve right triangle trig problems? We've been reviewing things that use trig and inverse trig functions. But if it is a right triangle, what else can you use to find some of the missing information? We just did a little bit of that, Luke. Don't forget Pythagorean theorem. And a right triangle is still a triangle. Don't forget that. What is something that we can use because it is still a triangle? Got it? We can still use triangle sum to get our angles. So keep all of those in mind as we are doing these. Let's try an angle of elevation problem, and then I want to talk about some things that are a little bit different on the worksheet that you'll be doing for your homework. So when you're doing these, draw a sketch. Never do one of these word problems without a sketch. It's a required part. I'll count off on your homework if you don't give me a sketch. Don't, though, do your most elaborate artwork, because that takes time, and I'd rather you just get homework done and have some free time. So I'm going to do some bad drawing here, and I've got this man. I'm not trying to draw anything fancy, and he is 200 feet away from a tree. There's my bad tree. It's my lollipop. I want to know how tall the tree is, so this is what I need to find. And then let's be a little bit careful. See, we know that the man is 6 feet tall, and he is going to look up to the top of the tree. Are his eyes on his feet? His eyes are in his head, so we're going to assume he's really, 6'4", that his eyes are 6 feet from the ground. And that angle is 11 degrees. If we let this part be H, and then this part is 6, the tree is H plus 6 feet tall. Does that make sense to everybody? So now, if this is 200 down here, this side is also 200. And notice I put my 11 degrees with a horizontal side. I didn't do something weird and say this was the 11 degrees. I could figure it out, it adds up to 90, but that doesn't do anything with this problem. The 11 is what I want. The H is what I'm looking for. It is adjacent, opposite, or hypotenuse. H is opposite, what about 200? Which ratio? Opposite and adjacent. So I'm going to write down tangent of 11 is H over 200. So H is 200 tan 11. Put that in your calculator. Everybody have that? We really want plus 6, so do a plus 6 now. And Sarah, what you got? Anybody else? 44.876? And we label that feet. Questions there? Okay, I'm not going to go through this whole one, but I want to remind you, if x is in the denominator, so far we've been doing things 200 tangent 11. If x is in the denominator, remember you can switch one diagonal, and x is 12 divided by sine of 32. Or you could go through and say, I'm going to multiply both sides by x. And then I'm going to divide both sides by the sine of 32. And you've got the same thing. So be careful when you're doing that. Some of the problems in the word problems will have things where maybe, you know, this is 50 and this is x. So this whole side is x plus 50. Maybe you'll be doing something with this angle, and maybe you'll be doing something with this angle. So tangent, because I've got opposite and adjacent, I would say the tangent of 30 is the opposite over the adjacent. If I wanted to do the tangent of 20, it would have to be h over 50 plus dx. So you can combine variables on some of these on the worksheet. You may have to be adding some things together to figure it out. Another thing on the worksheet, you can have a fraction of a degree. And that's what these things mean. We're really only going to worry with the minutes. We're not going to worry with the seconds. So you're not going to have anything with a double quote mark on there. But this much would mean 9 and 32/60 degrees. That's going to be a pain to enter on your calculator. You could enter it like that. However, if I wanted to enter 9 degrees 32 minutes, a much faster way of doing that would be to say, so let's suppose that I want the, I don't know, suppose I want the sine, just because it's the first one, of 9 degrees. I'm going to do the 9, and then if you push the pi button, see a little circle for degrees? You hit that, and then enter so that it types that. And then we would do the 32, and then we'd go back to that pi button again, and under the E is a symbol for minutes, and then we do enter, write that in, and then we do enter again for the calculator to evaluate what that sign is.